Hi everyone, this is Rupa. I work as a cloud data engineer. Today I'm going to give you a quick overview on what an Airflow is and why choose Apache Airflow for data engineering workloads. So what actually is an Airflow? Airflow is a platform to programmatically author, schedule and monitor workflows. It has rich user interface which makes it easy to visualize pipelines running in the production. It is easy to monitor progress and also troubleshoot issues when needed. So why choose Apache Airflow for data engineering workloads? So it is one of the most powerful platforms used by data engineers for orchestrating workflows. As data engineers, all of us want to run our entire ETL workload faster, right? Today, Airflow is used to solve a variety of data ingestion, preparation, and consumption problems. A key problem solved by Airflow is integrating data between systems such as data warehouses, data lakes, and cloud platforms. Airflow can also be used to orchestrate complex machine learning workflows. It is designed as an orchestration as a code system and it can be heavily customized with plugins. So that is why it is widely loved by data engineers and data scientists. So Airflow provides us a platform where we can create and orchestrate our workflow or pipelines. In Airflow, these workflows are represented as DAGs. So what actually is a DAG? In mathematics and computer science world, a directed acyclic graph means a DAG is a finite directed graph with no directed cycles. In simple or layman terms, it is a set of instructions and it describes the order of tasks. I'll give you a simple example for that would be, so if you want to go from task A to task C, you have to go from task A and then to B and then to C. I will also give you a simple data engineering example. Let us assume that task A that will wait for a file to be delivered to the S3 bucket or Google Storage bucket, and also assume task B. It is the one that performs the ETL batch process on the file and deliver it to a data lake. Let the task C be a failure or success notification that is being sent to the email. So to summarize, a DAG describes the order of tasks and what to do when a task fails. A task is nothing but a job. Okay, now let's get started with the terminology of Airflow. What are operators, hooks, connections, variables, and XCOMs? So what actually is an operator? So task needs operator to perform their actions. Here, task I refer to as a job. So operator is nothing but a worker in simple terms who knows how to do their job. So let's take the previous example again. From task C, to send a failure or success notification to an email, you need an email Airflow operator to send an email. It's as simple as that. Next one is connections. So you obviously need to set up connections with the external systems, right? If you want to talk to cloud or on-prem data servers or APIs. So if you have worked with any ETL tools like Informatica or any BI tools like SAP Business Objects or so, it is similar to how you set up connections within the tools. So let us take the previous example again. From task A to perform task A, Airflow connection needs to be set up with cloud platforms like AWS or Google Cloud so that Airflow knows it has to wait for the file to be delivered to the S3 bucket or Google Storage bucket. What actually are hooks in the Airflow world? Hooks are nothing but interfaces to the external platforms and they use connections. So coming back to the previous example of task A again, it will obviously need an S3 hook to check for specific file landing in the S3 bucket. It's as simple as that. Okay, variables are pretty straightforward in Airflow. They are similar to environment variables you set in your Windows system or Mac or Linux or anything. So let's take the previous example of task C again. In that scenario, when you want to send a failure or success notification to the email, you can store email ID in a variable. It's pretty straightforward. XComs are pretty useful in the Airflow world. They are used to share information between operators. Suppose, for instance, if you have two operators that need to share information like a file name or a date variables or any small amount of data, that can be achieved by using operators like XCOM push and XCOM pull. Let's go back to the previous example of task A and task B again. Task A can push the file name using XCOM push so that it is available to the other tasks, and task B can pull the file name that has been pushed by the previous tasks using XCOM pull, and it can be used in the ETL process. They are very helpful. Before we start using Apache Airflow to build and manage pipelines, it is important to understand how Airflow works. Understanding the components and the architecture of the Airflow allows you to understand how its various components interact with each other and seamlessly orchestrate data pipelines. Okay, let's get started with the first component, which is web server. This is the UI of the Airflow. This can be used to get an overview of overall health of different DAGs and also helps in visualizing different components and states of each DAG. This web server also provides the ability to manage users, roles, and different configurations for the Airflow setup. The most important capabilities of Airflow web server are like monitoring DAGs, visualizing DAGs, providing API endpoints, configuration, etc. Airflow web server UI homepage provides a brief overview of statuses of all DAGs and their recent runs. This web UI also has a section for visualizing the DAG flow, like in a graph view or a tree view, which represents all the recent runs and the statuses of each task for these runs. One can also view other things like DAG code, time taken by the each task for each run, logs, and more to help debug runs. Airflow web server also provides a set of REST APIs that can be used to perform various tasks for triggering DAGs, triggering tasks, or getting status of each task instance. The web server UI also provides options to manage various configurations like variables, connections, and view the Airflow default configuration on the UI itself. Okay, let's come to the second architectural component of the Airflow, which is scheduler. This is most important part of the Airflow, which orchestrates various DAGs and their tasks, taking care of their interdependencies, and it manages everything related to DAG runs or task runs, or storing the DAGs and setting up the SLAs, and it makes it easy for the users to schedule and run DAGs on the Airflow. This scheduler is multi-threaded Python process that keeps on checking and parsing all the code present in the Airflow DAGs folder. While the scheduler orchestrates the tasks, executors are the components that actually execute tasks, which is the third component of the Airflow architecture. There are various executors that come with Airflow, such as sequential executor, local executor, celery executor, and the Kubernetes executor. People usually select the executor that suits their use case best. Sequential executor. This will only run one task instance at a time. This type of executor is suited only for debugging or testing DAG locally before pushing to the test environment. So if you go with local executor, it runs tasks in a more controlled fashion in different modes. This type of executor is suitable only for running small workloads on a single machine. For higher parallelism, we need to be able to distribute tasks to the multiple worker processes running on the different machines. Another type of executor is Celery executor. It is based on Python Celery, which is widely used to process asynchronous tasks. Coming to Kubernetes executor, it provides a way to run Airflow tasks on Kubernetes. Kubernetes launches a new pod for each task, while Kubernetes takes care of pod lifecycle, and the scheduler keeps on polling for task statuses from Kubernetes. Okay, let's talk about Airflow Metastore. Airflow supports a variety of databases for its Metastore. This database stores metadata about DAGs, their runs, and the other Airflow configurations like users, roles, and connections. The web server shows the DAG states and it runs from the database. The scheduler also updates the information into the metadata database. Okay, this section pretty much covers about the high-level architecture of Apache Airflow. It includes four main components like we discussed before, that is scheduler, web server, executor, and metadata store. Okay, let's summarize what has been discussed in this video so far. Coming to the first one, Apache Airflow is a great open source workflow orchestration tool supported by an active community. It provides all the features needed for monitoring and scheduling workflows out of the box. Additionally, DAGs can be easily programmed in Python, so it is technically orchestration as a code. So anyone with Python knowledge can deploy a workflow. It is much resilient on backfilling historical data and retrying failed jobs. Airflow facilitates a seamless ETL integration with the cloud platforms. Throughout this video, we have covered Apache Airflow architecture in detail. So the next video, we will focus on installing and running Apache Airflow locally so that we can easily test our DAGs. Thank you for watching the video. Hope you enjoyed it. Please like, share, and subscribe to Cloud Data Engineering. Thank you.